Alright, so today we are going to work with translations. Now, I'm going to jump over to this. If you end up getting into OneNote later, we don't need it open right now for what we're doing. But I did put a helpful video on translation if after today's lesson you're still kind of confused and you're not being able to do your homework. If you go to this YouTube link, and it comes up, it's another person that's doing the exact same thing that we are going to be working on with translations on a coordinate point, showing how here's the coordinates of the original and then how we come up with our second one. We're going to see that today with two different methods. This definition we're going to go ahead and write in your foldable. So on that first orange sheet, when you flip it open, you should see it says translation. To translate a figure, you slide it to a new location in the plane. All points in the figure move the same distance and direction. So that's going to be one of our big key points, is that when we go ahead and we move something to a new location, every point's moving the same. I liked it on Desmos because the one activity they had an orange line that went from vertice to vertice, and so it showed how they're all going to stay. Two examples. Once again, if you want to see these later, you can look at OneNote. I think I put the second one because I like this one better. Is in translation simply means moving without rotating, resizing, or anything else. We don't change our shape any other way. Every point of the shape must move the same distance in the same direction. So when I took this original figure that's kind of shaded right here, when it took it and it translated up, each one of the vertices, remember vertices is our name for our 2D shapes corners, they're all going to go the same direction.
But isn't like dilation what we'll later go into making it bigger or smaller?
So even when I look at this, I had this on here. The reason I use this link is because if you want to play with this later just to be looking at stuff, you can. Where if I move something, this is going to move it two ways. When I take this one, it's going to show how it went from one vertex to another, and it's changing. We can always change these. So each one of the vertices all goes the same one. The shape did not turn, it did not reflect, it did not bend, we did not change it any, we just slid it and moved it. You would see the same thing on this one, where all they're doing is taking our shape and sliding. That is our translation. So today's learning goal is that I can translate, or I will translate a figure in the coordinate plane. That is going to be what we want to do. We can do this activity. I guess it's getting up and moving that will help us. So why doesn't everyone go ahead and stand up? Just where you're at. Okay. Now, without turning your torso, so just stand as straight as you can, facing the front. Let's do let's see, I'm going to be doing my opposite of you, so we can do it together. But let's do 2 steps backwards. Oh, you should be facing the front of the road. Sitting. Okay. Brett. Aiden, you should be facing forward. Okay, let's take 3 steps forward. I know you guys can't really move. That's okay. Okay, let's do 1 step left. 1 step right. Alright, the whole idea, now go back to your spot and have a seat. The whole idea, the whole concept there is that you did not move your torso and that we just did translations. You were sliding, you were moving. You faced here, said 2 steps forward. I came here. Or I went to the right. Or I went to the left. That is our translation. It's just the movement. I didn't turn and face another way. Okay? If we get to this, actually in elementary I used to play the game. We play the Cha-Cha Slide song. But then I deal out instructions to the kids. And they had to have their eyes closed. And we had to see who would win. So I'd be like, slide left 2 spots. Turn 90 degrees to the right. And they had to end up falling over. So we might make it a competition later. Alright. So let's look at what I have up here. It says, identifying a translation. Tell whether the blue figure is a translation of the red figure. So, number 1, it's an upside down trapezoid. So, is the blue figure a translation of the red figure? So we have the red figure, that's where we originally started. And then the blue is our new image. Is the blue one a translation? Well, why? Yeah. So we would go ahead and say, yes, this is a translation. All that happened was all these corners moved the same direction. Brett, have your planner out. I'm going to be done. You're messing around talking about other things, not paying any attention. Okay? So if I look at this, it looks like all of them, each vertice, went the same direction, the same length. How about B?
No.
Haley?
No.
Why is this a no?
Because the rectangle is turned in the second picture. Or in the first.
This one, if we look, these turned. We turned. That is not going to be our translation. That is going to be our rotating. Dusty, facing forward for me.
It's not the location, it says rotation, translate, and edit, or
So, well, we're going to look at all the ones that you see. We're going to work on translating, reflecting, rotating, dilation, and looking at similar congruent figures. Today, we're only thinking about translating. Okay. Quickly turn, talk to the neighbor, see, are these two, and how can you tell me? Don't shout them out yet. You're not gonna
I do not see that.
Not really. It's older than this.
Guys, so when I ask you to turn and work with a partner on math, and we're talking about how old we are compared to each other, I don't think that, Kate, Brett, Dusty, I don't think that's anything to do with what I'm talking about.
That contains math.
Oh, well, you were turning to talk with them. I thought you were on the same thing. So, if you want to say that contains math and be smart about it, that's awesome. This is what we're discussing. If you're going to do other things, like I said, you are going to leave. And it's okay. What? So, okay. Well, then we don't just start messing around. We get ready. All right. Evan, what do you got for number 1?
number 1 is no, and number 2 is yes.
Okay, well, why is number 1 a no?
Because it's a smaller size of everything.
Yeah. This one, I want to say yes, because it looks like, hey, they went this way, this way, this way. It looks like it translated. But the other thing is, it got bigger.
Yes.
So that's going to be one that we will talk in the future. So this one is definitely a no. Number 2 is yes. All it was is simply, we moved. Okay. If today's homework was that hard, it'd be a breeze. We're going to kind of take it to the next level. Translating a figure in a coordinate plane. So, translate the red triangle 3 units right and 3 units down. What are the coordinates of the new image? Now, we have 2 methods that we're going to use this on. Either one is acceptable. To be honest, I probably use the first method more, but I know it's kind of funny. I do both. I use the first method, and then I double check myself with the second one. The first method is, I'm going to look here, and it says, I'm going to use the coordinate plane. So my first rule was it said 3 units right, and then I'm going to do 3 units down. So what I'm going to do is method 1, I'm going to go to each vertice point. And I'm going to underline this in blue so you see I'm doing this one in blue. I'm going to go 3 units right. So 1, oh, you're not ready. Board went off. Alright. 1, 2, 3. I moved that one 3 units. But then I'm also supposed to go 3 units down. 1, 2, 3. This is going to be my new point, but that's my new point for B. So I have to do this for each one of them. So C, I'm going to go 1, 2, 3. 1, 2, 3. That is point C. For A, 1, 2, 3. 1, 2, 3. And with that, now I can connect my dots. If I was, whoa, that really curved. So I should try to make it as straight as I can. Oops. Okay, that would be my new point. So the first method is actually pretty simple to do. You just have to make sure you're following the rules, and since there's 2 of them, I'm going to show that I went 3 over, 3 down. Each coordinate point, and then I relabel each one. That's fun. The other method is going to be using addition subtraction. The way we do this is on A, I write down what its coordinate points were. A is at -2, 1. B is at 2, 5. C is at 1, 2. Okay. The way we do this is if they tell us to move left or right, which coordinate is that affecting? My X or my Y?
Left to right.
Yep, left to right. It affects X. X is my left and right one. So if it tells me to go up and down, that affects my Y. So here, when it said 3 on the X coordinate, because I was supposed to move right. Now here's the thing. If, I want to make sure everyone understands this. For on my X axis, if I move right, I'm going to be adding, which makes sense. We're getting bigger numbers, so we move right, we add. If I move left, I will be subtracting. When we look at our y-axis, if I'm supposed to go up, I'm going to add. If I'm supposed to go down, I'm going to subtract. So what I'm going to do method 2 is simply, they told me, I'm going to rewrite this. My X was -2, but they told me to move 3 to the right. So I'm just going to say -2 plus 3. My other coordinate was 1, and they told me to go down 3. So I would say subtract 3. That would be my coordinate points. Okay. So this is how we're going to do method 2. All I'm going to have to do is say my original coordinate point, -2, -2, 1, 1. and then I'm going to add or subtract whatever they told me to do. So they told me to move 3 to the right. Negative 2 plus 3 is what? What is negative 2 plus 3? It's 1. So my new one is going to be 1. Negative 1 minus 3 is. So my new coordinate point for A should end up being at 1, negative 2. If we look at what we did, 1, negative 2. That is where A ended up at. If we do B, I'm going to show what my new coordinate point would be. I'm just going to do my work right here. I'm going to say, okay, X was 2, and I was supposed to go right 3, add 3. Y was 5, and I was supposed to go down 3. For C, I had 1, I was going 3 to the right. I had 2, and I was going down 3. We solve these, and it's that easy is all we have to do. 2 plus 3 is 5. 5 minus 3 is. So for B, my new coordinate should be 5, 2. For C, 1 plus 3 is 2 minus 3 is negative 1. So my new C coordinate should be at 4, negative 1. If we look, our new coordinate for B was at 5, 2. C was at 4, negative 1. No, put it down. If I ask again, you just come spend every lunch with me. It's okay. You know the rules. So, these are our two methods. All of them are fairly simple to follow, and we're going to try practicing them, and that's what we're going to assess you on today. That's what we're going to be doing for our homework. You're going to have a shape, and you're going to use, we're going to make sure that you can do both methods today. We're going to make sure that you can use the coordinate plane like we did, or we could add and subtract. So, you try. I believe this is the one that's in your foldable. Oh, this first one was that one. All right, so let's have you guys try. The vertices of a triangle are A, negative 2, 2. Okay, so negative 2, 2. B is at 0, 2. That's okay. We'll do it up here together. And C is at 3, 0. Alright, that's okay. We'll just do this one up here. Alright. Translate the unit. So I want to see if we use either method, what we're wanting to use. Let's go ahead and try this. Translate the triangle 1 unit left and 2 units up. My first thing I would do is I pay close attention that I'm going 1 unit left, 2 units up. So here's my 3 points. A, B, oops. I actually didn't pay attention, I just wrote it. A was negative 2, 2. So A, B was 0, 2, B, C. Okay, who thinks they can come up and put, where would coordinate A be? Where's the new A go? Will, you want to try it out? Which method are you going to use? Okay. Alright, so did you move 1 unit left?
Yes.
Did you move 2 units up?
Yes.
Okay, there's the new A. Who can do B? Dusty? Probably reflections and rotation. Okay, you go 1, even if it doesn't show, it's okay.
Go back up and click.
Oh, you gotta click on that pen. There you go.
Click off left.
There you go. Hold on.
That was a high reach there.
Good, Dusty. So 1 over, 2 up. Okay, and I need someone to do C. Kate? Yeah, I was gonna say, make sure you put the point. Then, the last thing we have to do is we would draw our picture. That is how we use method 1. Remember, method 2, we're going to show it real fast. If I said A was -2, -2, to be honest, another thing I would maybe do to show my work is I would just stack them. 1 unit left. So that means I'm going to go left, -1. I'm going to go 2 units up. So +2. And when I add these, my new answer for A, for the new triangle, -2 minus 1 is -3. -2 plus 2 is 0. Is A at -3, 0? Yeah, that's all there was to it. If I did B, B's original points were 0, 2. So, who can come over and show me how to do method 2 on B? How do I find the new coordinate points using method 2, the addition subtraction? It'll be tricky if we can't do it. We have to do it for today's homework.
You have to.
Okay. Well, what do we do to the x coordinate? What's it tell us to do moving left or right? Left 1. So if we go left, that means to add or subtract. So I'm going to look at my x coordinate and I'm just going to subtract 1 from it. So yeah, you can do it right now. 0 minus 1 is -1. But then for my y term, y is up and down. What did it tell me to do? Up 2. So is that adding or subtracting? Going up is adding. 2 plus 2 is 4. That is my new term. So if I look at B, -1, 1, 2, 3, 4. That's where we were. We try the last one. I'm going to do it right over here. C. C was at 3, 0. Anyone think they can show the work now? Same rule because all of them are the exact same. Yep, that one someone else has it. Haley. Alright, what do you think? So we -1 plus 2. We should get C to be at 2, 2. 1, 2. 1, 2. It's correct. This is what I want you to see, though. That's the important thing about translation. All the points had to move the same. They went the same direction, the same amount. So if I minus 1 plus 2 on each one of the vertices, I will add or subtract 1, add 2. If this was an octagon, we would add 1, we would subtract 1, add 2, but we would do it 8 times, 1 for each one of the vertices. This is the one that's in your notebook, and this is our last one. So we'll finish this, and then I'll look at homework with you. Maybe help you out. So a landscaper, you want to do this in your foldable. A landscaper represents a park using a coordinate plane. Can't read today. He draws a square with vertices of -1. What is my deal? With vertices, A is 1, -2. So here is my point. A is 1, -2. B is 3, -2. C is 3, -4. And D is 1, -4. So I'm going to go ahead and first, let's put those in. So on your foldable, please do this with me. It says 1, -2. 3, -2. So that's A. B. C is at 3, -4. C. And D is at 1, -4. Okay. You should have something like this in your foldable. Donovan, doing this with us, please. Now, city officials want to move the fountain 4 units left and 6 units up. Find the coordinates of the image. So that's one of your answers. I need you to tell me what is A, B, C, and D, and draw the original figure and the image. You can use either method that you feel comfortable with right now. Which one do you think is going to be easiest for you? Do you like method 1 where you use coordinate plane, or do you like to add and subtract? First one? I'd agree. For the most part, for what we're doing small changes, that's easiest. If it's a bigger plane or if there's other things on the plane, sometimes I like to just do math. So let's go ahead and do this. The way I would show this is you don't have to show all the parts, but I'd just say 4 left. 1, 2, 3, 4. And 6 up. 1, 2, 3, 4, 5, 6. That would be A. 4 left, 6 up. Same thing on this one. 4 left. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And obviously, C better be here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That would be what I need to see. So if you look at yours, check. Does it match with me? Donovan, are you doing this with us? Okay, I should see your second one then. For your homework tonight. Hey, I didn't write you guys' stuff up here. We were doing lesson 2.1. I'm sorry, I didn't realize I didn't write it on the board. Translation. Yes, your homework is lesson 2.1, and this is in your homework sheet, that little foldable. I will show it here in just one second when I get over there. Really should not take you too long to complete. Alright, if we pull up this. Alright. Here's our homework foldable. And opening up the first, for each figure, describe the location of the blue figure. Well, we can't tell which one's blue. So we'll just say the first one's on the left. Pay close attention to this because I'm changing a little bit what I'm asking you to do. Let's zoom in on this. Okay. I want you, on the first two, you're describing the translation from the figure on the left to the right. Now, when you do that, I want it to be just like it was on our examples. When you're describing how it changed, you need to say 3 units left, 4 units up. That's what I want you to do for describing the change. So, if you were doing our last example that we just did on OneNote, and it was this, you would have said 4 units left, 6 units up. That is what you are doing for the first two. Describe how did it translate left to right, up, down. Hold on, let's finish this and then I'll get to you. On number 7, 8, 9, 10, 11, 12, all you have to do is say yes or no. Are they a translation? If you want to put Y, N, I'm totally okay with that. Not a problem. And then your last two questions, you need to translate each shape. The one's a triangle, one's a trapezoid, and it tells you how much. I need you to redraw the new shape. You can use either method for today's homework, though. Method 1 or 2. Any questions? Leslie. I'll look at it with you. Okay. Go ahead. You still have work time. You should be able to finish the majority of this.